Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology with the leaders and innovators to make it all happen. On today's episode, we're absolutely honored to welcome Lisa King, Director of Advanced Battery Strategy, Leap Manufacturing, and Jeff Yambrick, Chair of the SAE Battery Cell Standardization Committee. On today's episode, we'll explore how SAE JA1016 and how this standard could improve battery safety and strengthen the future of electrification. We hope you enjoy this episode. Jeff, Lisa, welcome to the podcast.
Thank you very much. Glad to be here.
It's great to have you here because this is a highly technical conversation, but it's also a very important conversation. And Jeff, we're going to kick this conversation off with you, sir. Without a common technical language for cell size and testing, things are bottlenecked by a lack of interchangeability. It happens. Is this what JA1016 is hoping to achieve to overcome?
Yeah, that's exactly what we're trying to overcome here. Right now, the market is relatively small for the uncrewed aerial vehicles, and it's custom by default. So again, I don't care if you're the military, I don't care if you're the commercial side, everybody kind of does their own thing. And again, it's equivalent to what happened, 20 years ago when electric vehicles started coming out. Every cell supplier has a different footprint, especially on the pouch side. So what this really does is it tries to commonize for a number of reasons. There's a physical envelope from the standpoint that we want to be interchangeable, simply, in my opinion, to really drive more commercialization. The goal is really not to freeze the innovation, but it's to standardize the interface so that when you look forward, you have a certain amount of cell sizes that are applicable. So you don't have the Wild West of 20 years ago where you had, I remember John Warner, I think, did the original cell standardization. And I think at one time he was telling me, I think it was like 123 different cell sizes. Really can't commonize, really can't go into production at high level as to reduce cost. So it's really driven the reason for this. So I would say one final thing, good way to frame it is that we're trying to move this market from custom cell to custom pack, custom qualification towards a standard envelope qualification and faster integration.
I'm going to ask you the big question, is the overarching goal here to get ahead of the growth that is coming in this industry before it takes off, to have some sort of standardization to kind of, use the term, act as a rocket pack or a booster to help lift it off?
Yeah, in my opinion, yes. Again, if you allow all the people in group one to identify their own packaging space, as opposed to the industry, the battery industry identifying it, it will take off much quicker. Again, even EVs and other applications, because it was so random, it's taken a long time to get to that standardization. If we get out in front of it for this application and future applications as well, the time to market much quicker. When you have that standardized envelope, that standardized pack, that standardized cell, everybody knows from a drone perspective what they're building to. Now, that doesn't say that, somebody can build a very specific one and want to go off and do their own thing. But in this case, we're giving them all the parameters, all the tools, all the qualifications to be able to say, here's what you're building towards, or here's your building space, here's your qualifications. If you need something beyond that, then that may be a discussion with the cell manufacturer. But this really helps to move the industry forward.
Lisa, before sanitation, let's call all these moving parts. To me, I'm sitting here as a layman. Oh boy, complication central. How does this affect system designers? Are they cheering you on and say, yes, standardization? We can focus on building really great products. Is that what's happening?
Yeah, believe it or not, when we first started this, there was a lot of pushback, right? And you can imagine that the OEMs were like, well, I have my proprietary thing and I want it to do what I want it to do, and I want it to be a certain size to match to my vehicles. But at the end of the day, the battery piece has been an afterthought. So they build the vehicle and then they attach the battery pack later. And so once they realized two things, one was that, they needed to start thinking about things in a more systemic level. Like, the whole thing operates as a system. Maybe they have platforms where the same battery works on different vehicles, or they have a vehicle that uses different batteries, but they needed to start thinking in that manner. The other aspect of this is the FY26 National Defense Authorization Acts, Section 842. And that is going to create some difficulty among the pack manufacturers and the OEMs, in that the batteries themselves have to be primarily non FEOC, and I'll explain what that is in a second. They need to be contain non-FEOC materials. And FEOC stands for Foreign Entities of Concern. So from a U.S. Department of War perspective, they are now examining the risk in obtaining batteries solely from one country, and that is China. And so because they would like to spread that risk around now, then it's necessary for there to be industry outside of China. And to do that, we have to standardize, because there's no other way to build capacity.
You're correct about the standardization, but before we go down that path, you brought up a very, I'll call it, interesting point that I'd love to get your take on, and Jeff, love to get your take on this as well. Battery's an afterthought. Well, where's the power going to come from to move if you don't have the battery? To me, it seems like, okay, that should be first thing on the drawing board. And then yet, no, we don't have it on the drawing. Oh, we need something to move it. Why is that the afterthought?
I can tell you, I've been a battery engineer my entire career, but when I have worked with systems engineers who build the product that's going out into the world, frequently they just view the battery as a power source and not something necessarily that is an integrated part of the system. So they may think about the motor, and in terms of how much lift I need or how much duration I need to run this particular application, and then they just look for a battery that meets that. Where from a battery engineer's perspective, the system works as a whole. So you have your charging, you have your powertrain, that's your motor, and your electronics array, and then you have your power source, and they all work together. So believe it or not, that is a thing in an OEM environment.
I'm curious, Jeff, what are your thoughts on, well, we don't really need it until we need it?
I would certainly echo everything that Lisa said. Having played an engineer at work for a number of years, I would totally agree with Lisa's assessment. I think part of it too is that if you use the automotive industry as kind of the platform for which things get built, or maybe the model for which things get built, a lot of times the designer of the vehicle, if you will, considers certain components to be off the shelf. Lead acid batteries, there's only maybe 150 PCI sizes, so they'll find one that works. A lithium-ion is significantly different, both in performance and space allocation. And I think that the mindset is that a lot of times the battery, we'll find one that fits when we need it. And really, they should be, because the battery is such a main component to this. I mean, it is the engine. It's the engine and the gas tank, if you will. And that they really need to be considered in the initial design phase of any application. And they are a considerably costly component to actual the vehicle itself. Again, whether it's the aerial vehicle, whether it's a ground vehicle, whether it's a stationary power, whatever it may be, the battery has to now become considered as part of the core design.
And as Lisa pointed out, I'll use the term, I won't use alphabet soup, but we'll use the term, there's regulations that you have to abide by. And I'm curious, so if you wait till the last minute, it seems to me, Jeff, that you could potentially have supplier lock-in. Okay, so we're going to go with supplier Acme, and then all suddenly, to me, that becomes an emerging risk, because all suddenly, if supplier Acme has an issue, it's like, okay, now where do we go? When did the individual start to think about supplier lock-in when they're developing this technology?
Again, in my opinion, that should be really upfront as well. You can't build a vehicle, again, whatever the vehicle may be, and then start picking suppliers. Simply because you might have a supplier that has the right chemistry, but maybe not the right format or fit. You might have the right fit or format, but it doesn't have the correct qualifications. So it really is beneficial when you're designing any vehicle to keep the major component suppliers, nuts, bolts, things like that, fine. But when you're talking about a motor, a battery, certain parts that are need to be commonized from a high growth standpoint, it really needs to be considered up front. And really, that's what JA1016 does. It says, okay, in the future, all of you cell manufacturers, all you pack manufacturers have this space to live in. It's up to you if you want to choose to use that space or play in that market. But if you're going to, this is a space you're going to have.
And that's a really good point here. Lisa, JA1016 bases pouch cell dimensions on compatible existing 21700 Cylindrical cells. Why is that?
So at least within the military space, there are a great deal of battery packs that are manufactured using cylindrical cells. And cylindrical cells are somewhat commoditized in the market, 18650s and 21700s. They can be purchased from many different suppliers in many different configurations. At one point, when I worked at Stanley Black & Decker, we had well over 40 different cylindrical cells that had different guts, but they were the same shape form. And they were all used for different types of product. So you have the same thing happening within the UAS space. So what we found was that the more powerful battery packs, the ones that needed more runtime, so more duration, they were tending to now specify 21700 cells because they could get that higher energy density, they could get that higher power levels. They had better thermals than the 18650 cells did. However, some of the cutting edge vehicle manufacturers have started to go to pouch cells. And there is a design difference between the two, other than the format, but that has to do with how the electrodes are arranged within the cell. And so cylindrical cells tend to get a very hot core, and like they don't release their heat as well. The heat transfer is not as good. Pouch cells being very planar, having larger surface area, they can dissipate that heat better. There's also a construction difference in that the internal resistance of the cell is much lower because you have many tabs connected, or a continuous tab connected to the outside. So we found that many of the bigger UAS suppliers were starting to use pouch cells, but those are only coming from China. So that's why they wanted to mitigate that risk by, okay, I can use a 21700 if I can't get this cell from China, until we could build a supply chain elsewhere.
Now I have to put on the I'm not an engineer hat, but I'm a curious hat. What impact does that have on manufacturing?
Ooh, huge. Um, so we talk about cylindrical cells in a manufacturing environment. It's a well-established product. There are hundreds of cylindrical lines in the world right now. They're running at very fast speeds, and we're talking about 300 to 400 cells per minute. A pouch cell is a much slower process. It takes I think the fastest lines are running somewhere in the 100 parts per minute range. So maybe one quarter of the fastest speeds. Couple that with the very custom nature of those footprints. Top manufacturers may have well over 100 different size cells in their line card. Where cylindrical, it's 18650 or it's 21700. Now, they may They may play with those within the tolerances of those dimensions. However, they're still 18s and 21s. But those pouch cells are so varied. It really does help them aggregate demand so that they can run faster, they can make better investments in the future.
You're taking something that's massively complicated and making it a little bit less complicated. Is that the right way to summarize that?
Yes, I think so.
Well, to me, that unlocks performance. Jeff, from a performance perspective, what does JA1016 unlock?
I would say amongst the greatest benefits of it is from a standardization standpoint, your production suddenly becomes understandable. And what I mean by that is imagine creating a drone for some government function and then realizing that nobody on the planet can really make that cell. And then you have to go back and say, okay, well, we can make it, but it's also going to cost you, $20,000 a cell. So by standardizing it, it alleviates a lot of the issues around unknowns. When you have a specific qualification, when you have a specific packaging space, when you have a specific cell size, so again, between packaging and cell size, you know what the stack up will look like. So by standardizing, it really eliminates a lot of unknowns, and not only eliminates them, it puts them up front. It puts the knowns up front. So you know what you're getting into when you start designing this.
So you're staying today, but the battery industry across all vehicle types is just moving at such a rapid pace. As Lisa correctly pointed out, you have the regulatory issue there. How do you, as the committee chair, stay ahead of this to ensure that the standard is always at the forefront and not of coming up from behind?
Yeah, again, we're going to review it, every 6 months, every 12 months. I think it's also upon not only the leaders, the participants, that industry also has to raise flags when they see something that could change it, might need to be included, altered, whatever that may be. So again, on our side, as the people who ran it, the people who wrote it, we need to be aware of what's going on, and we need to bring that up. But again, because we are individual volunteers working in our own spaces, it's really upon the industry to review, raise the hand when something new comes up, a new development, whatever it may be, so that we can stay ahead.
I'd like to I'd like to add to that. So there is a way in which we crafted this that allows us to use backward looking technology, right? So when we created these size standards, we did quite a market look to see what is being used now, and we tried to make sure that we were on target with those cells being used today. But we also left it chemistry agnostic so that future technology can then be put into this format. So we're not specifying performance, we're not specifying chemistry or anything like that. It is simply the footprint and the thickness. That's it.
I'll symbolize this way. You left wiggle room, which I like. You left wiggle room. But then the hard part becomes interpretation. How do you manage you have the wiggle room, but then, I'm sorry to say, individuals interpret things in different ways. How do you balance that?
So some of the things that we did require the proof of performance, right? So you're giving them this envelope that they have to put their technology into, right? You're allowing them to choose their tab configuration. So tabs on the same size, tabs on opposite side. And for different types of cells, you may want one or the other. We're also requiring that those cell manufacturers perform a group of tests that to sort of conform their performance data in a certain way. So an OEM can look at that data and say, okay, I see how this cell is different from this cell here. And it is kind of keeping them in the lane instead of allowing them to just showcase whatever they would like to. It really kind of keeps them in line with how this is standardized in some way.
Is that where the standard requires I'll say a specific amount of testing? Is that where that comes in? So you might have that wiggle room, but okay, guess what? There's a baseline for testing, and there's no wiggle room on that baseline.
That's right. That's right. There are certain certifications required, and then there are tests, and the way that that data is presented is standardized as well.
One of the interesting things about JA1016 is that I'll use the DoW term. It's dual use application. So you have military applications and civilian applications. Why, Jeff, take that dual use approach on day one?
For what I will call the obvious facts or the obvious reasons, given that I spend a lot of time on the commercial side and the strategy side, which is if I can use a product that's being produced in the thousands, tens of thousands, hundreds of thousands, and the military has the option to take something off the shelf, which again, JA 1016 does, suddenly they're not at risk of requiring batteries that they may only have a run of 3 months for. Suddenly you have a plant that you built for the military, and you have this plant that's running 3 months full speed, and then they go, we have what we need. And then it's like, okay, commercially, how do you actually do that as a company? You either have to charge essentially 4 times as much for those cells, or you have to commercialize them in a way in which they can be used in other applications. There's a few case studies and actual businesses that they have a 10% plant for military, 90% of the plant is running for commercial products. And it makes perfect sense because suddenly your overhead, all of your capital is not being spread across 3 months worth of volume over a 12-month period. It's now being spread out against more of a commercial side versus just a purely defense side.
Lisa, from a manufacturing standpoint, do you potentially think that could lead to an increase in manufacturing domestically to meet all the rigorous regulatory things that are out there because it's dual use?
Short answer, yes. You know, we already see large companies like Skydio. They are making vehicles both for commercial use. They're used in police action. They're used in firefighting. They're used in inspection. But they're also used. They have models that have a specific, like, slash unit that is the same unit, but it's used for military purposes, and they will use the same battery pack. And that's the way to go. And to have manufacturing here in the United States helps them reduce risk because they have something close by and it meets the requirements of the NDAA.
I mean, on a personal note, I've known the Skydio team for a long time, back to their pre-Andreessen A16 investment, and they built some good products. And not to go off topic, but the autonomous tracking software that they built early on, it did a phenomenal look, and look where the company is today. Jeff, I want to stay on the military aspect because there's something very interesting here. The JA 1016 notes the battery packs developed on U.S. Navy vessels or aircraft must be tested to the NAVSEA S9310 standards. So how does the framework help bridge that gap between commercial off-the-shelf development and these highly stringent Department of War requirements?
Yeah, and I would say that firstly, JA 1016 doesn't replace the NAVSEA. It's very important to make that clear. What it does is it really is a commercial development move in the direction that's more capable with or compatible with defense qualification. It does create a better front end discipline, define geometry, again, the space, the performance, etc. And it matters because defense qualification can be very expensive and rigorous. So again, if we say you have to meet this, then upfront you're doing a lot of that. If the commercial pack data is weak, unclear, swelling behavior, etc., then you create a very large issue from a military side. So again, I wouldn't say that again, I wouldn't say it replaces it because it does not, but it definitely is kind of the front end of telling the cell manufacturers, the integrators, what they have to meet in order to actually be considered.
And Lisa, one of the other things that the standard does, it standardizes data. So to me, from a supplier standpoint, that's going to have a positive impact on these companies that are looking for the technology. What have you seen, or could you see happening in the supply chain now? There's going to be standardized data.
You will see, I think, new technology being used at a more rapid pace. If a supplier, a new player in the market, has a technology that excels over what's available in market by testing with prototypes. So if you have new technology company coming forward, and they can make prototypes and test them to this standard, they can get that information out to potential customers much faster. And it will be put up against existing technology and other new technologies. And so it does give them leverage to put their foot in the door with those customers.
Jeff, the JA1016 talks about maximum life thickness rather than the beginning of life thickness. Why?
Yeah. So when you look at a pouch cell, it does swell over time. And then it's very dependent on the requirement of the battery. If it's there for standby power, comes on, once in a while, you're fine. Packaging space probably doesn't really matter that much. But when you're talking about more defense applications, you're talking about applications that are intended to be somewhat rigorous, and those will swell over time. So if you simply say that XYZ is XYZ, in the beginning of a life, we know that pouch cells will swell. Nature of the beast. So by identifying end of life packaging space, then you essentially secure that what a cell manufacturer might be doing is they know what their swell rate is. They share that with the integrators, or they build the packs themselves. They know by the end of the life of that application or that cell, it will still fit there. Otherwise, you're on the risk of, outgrowing your packaging space, which then creates a whole nother problem.
And I don't mean to extend the problem, Lisa, but unfortunately, there could be catastrophic power failures that could happen. Not saying they will happen, could happen. How does the standard address that issue? Potential issue, I'll say.
So we do require standard safety testing as part of this package. That's UN 38.3, which is a transportation standard, and the UL/IEC 62133-2, which is secondary cells and batteries testing. So those are all safety requirements. And so at least at a bare minimum, we're ensuring that safety level at the cell level. At the pack level, depending on where it's going to go, there will be the NAVC standard. There will be some other qualification standards. But, inherent to battery cells, the safety is paramount, and that's whether you're a cell or a packer or an OEM. You really need to ensure that your product is going to be safe, and that's what those certifications are for. I will say that having testing outside of the box, so trying to determine that safety envelope is really important, and also making sure that your cell and pack suppliers are high quality. And that's about as far as you can go with it.
It goes back to the old Ronald Reagan saying, "Trust but verify," and it really has to happen. I want to zoom out and ask you the big question. We'll start with you, Jeff. What is the future of uncrewed aerial vehicles?
But it's a great question. And actually, your question previous to this is going to be very important. What happens when you have a failure midair? But you look at it, and you look at Amazon, you look at agriculture, you look at safety and monitoring. Um, I mean, it's going to be, in my mind, absolutely huge from the standpoint, again, when you're starting to um, do more of mapping of the globe, meaning we have maps and everything, which is fine. but we know that there's more reasons to do it, whether it's looking for rare earth materials or minerals. Having these applications is going to be paramount. I mean, I won't put any numbers on it. I will just make one up. But I can imagine in the next 5 years that it will be a common sound where you're getting your pharmaceuticals delivered. I know there's some programs in Africa that do that today because they're so remote. You'll be getting your Amazon packages delivered. Then that brings up a whole new problem: is what is the regulatory space for those? I think those two areas probably need to start having more conversation if they are not today. But again, imagine 350 million people in America. I forget what Amazon's subscription rate is, but even if it's 20 million, 100 million, imagine how many drones are going to be needed. And so I think commercial space is going to be, or in the commercial space, the home delivery is going to be huge. Agriculture is going to be huge. Um, Mapping for materials, maybe not as large, but just as important. You can't have an industry with a limited supply. So you're going to have the ability to find it in remote places that can do it relatively quickly. And so in my mind, it's going to be absolutely huge. Let's just hope they can keep the noise down to a minimum.
That you hit the nail on the head there, Jeff. The noise. They don't want to hear over your head because people do all sorts of weird things. But you're right about the industries, ag especially is going to be super, super interesting. Lisa, in your opinion, what is the future of uncrewed aerial vehicles?
Yeah, so I mean, not to stay limited necessarily to aerial vehicles. We're seeing the rise of autonomy across different types of vehicles. So we have aerospace, we've got undersea, we have ground vehicles. It's just and robots just generally, and all of these are presenting new applications but new challenges as well. So I will say that one of the new things that we're working on now that we've sort of wrapped this group one is we're going to be moving into the two next largest vehicle classes for UAV. So that's group two and group three. And within group three, you've got very large vehicles that could even be potentially human carrying.
You're moving on up. So when we think of Group Three, should myself, is that the Joby vehicles, the Whisk vehicles? Is that the type of vehicle that we should think of for that?
Yeah, so group two is 20 to 55 pounds of gross weight. And then group three is 55 pounds to 1,300 pounds. Right. So it's a very broad category, but yes, you're talking about the Jobies and the like.
And I will to the Whisk has hosted me at their headquarters, and I got to put their VR simulation on, and I gotta say that was super cool. They showed me this VR simulation in Houston. It was super cool. And this has been a really wonderful conversation, Lisa, Jeff. As we look to wrap up, what would you like our listeners and viewers to take away with them today? And Jeff, we'll start with you, please.
I would say that a couple of things, because I'm never shy for speaking. Um, this is a necessary step forward. The intention is not to slow any innovation. I have been a longtime proponent that manufacturing is what drives industry. Innovation, great. R&D, super. These are the things that create air conditioning. It's the things that create the electrolyte that goes in. Sorry, not electrolyte. The antifreeze. In fact, brain just went blank. I was reading something the other day that between like 1920 and 1930, that people would in the north would park their cars because they had water in them, and it would expand and ruin things. So innovation is absolutely necessary. What I have been probably pounding my fist on the hardest is that we cannot continue to create chemistries thinking that we're going to create one that's going to be the greatest thing ever. Meaning, it's if we keep innovating, we keep playing in R&D, and we don't actually get back into a factory, we will be reliant on the rest of the world for energy dependency in the future. And what do I mean by energy dependency? I mean physical AI. And again, drones, data centers. Imagine if we can't make anything in this country and we have to go elsewhere. Fiat has already told us what we can't do. So we would be in a great deal of trouble. So my opinion of this a standard is that we're not trying to slow down innovation. What we're trying to do is put a standard in place that allows people to go into production. Again, we just had the conversation about what other drones. I could imagine more drones are going to be created annually in the next 5 to 10 years than vehicles. Automotive, excuse me. So I think it's very important to recognize that innovation will come along. There's whole departments at different companies and the government and everything. But getting into production is the most important thing in my mind, and then letting innovation and R&D be a part of that. And it's always great to be able to fund your R&D and innovation if you have production. So that would be my biggest takeaways. We don't want to stop innovation. We actually want this to help innovation. We want it to help innovation from the standpoint that let's go into production. Let's start making these things. Let's help the drone industry out by creating a standard that allows them to create hundreds of thousands, and then use that to do more innovation. And again, through that greater production in both batteries and vehicles, then suddenly you have more applications that grow from that. So that would be my biggest takeaway.
I love the vision. Lisa, what would you like our audience to take away with them today?
Yeah, I 100% agree with Jeff. We have an opportunity through this standard and other things that we're doing in our country to bring manufacturing back here, to bring battery manufacturing online. We have to do this. It's not just for UAVs, right? And that, UAVs are becoming increasingly important in our lives. However, we need ESS to stabilize our electrical grid. We need electric vehicles to reduce our reliance on foreign oil. So there are, many reasons why we need to bring the manufacturing for batteries here to this country and to allies as well, I would say. But yeah, I think that's the number one goal we have right now.
It's time to build. Today is tomorrow. Tomorrow is today. The future is SAE JA1016. Lisa, Jeff, thank you so much for coming on SAE Tomorrow Today.
Thank you for having us.
Thank you for having us.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.